Hello, today we're going to talk about rotations, which are another transformation in the coordinate plane. In a rotation, as you might think of when you think of the word rotation just from outside of math in your everyday life, you are turning a figure about a fixed point that's called the center of rotation. And how far you've rotated it, or the angle of rotation, is formed when you draw a ray from the center of rotation to a point in its image. So rotations are like turns, reflections, which we've talked about before, like mirror images. Translations are like slides. In this picture here, you can see that we have this pre-image QPR or QR, and then we are rotating it 40 degrees into R prime, and that triangle is staying the same size. The angles are staying the same size. We can rotate figures as many degrees as we want to. A lot of times we think about things like 45, 90, etc. We can rotate anywhere in a circle. All the way around a circle is 360 degrees. Halfway across a circle is 180 degrees. And if we were to go more than 360 degrees, it would look like an angle that's smaller than 360 degrees. We are going to focus on, for now, rotating counterclockwise about the origin and rotations of 90, 180, and 270. Remember that counterclockwise is the opposite of the way an analog clock goes, which is this direction I just outlined with my mouse. So, just like we had some coordinate rules for reflections, we have some for rotations. If I am rotating 90 degrees counterclockwise about the origin, so I'm starting this blue point AB, if I'm rotating it 90 degrees, the coordinates of that new point are negative BA. So we change the order and make the new x coordinate negative. If we are rotating 180 degrees, they don't have that in the picture here. Oh, I'm sorry, they do. That's the green point. The green point, if I rotate 180 degrees, becomes negative A, negative B. So both coordinates become negative. A rotation of 270, which is all the way around to this black point, turns AB into B, negative A. Part of what we're going to do today is graph some polygons in the coordinate plane and rotate them the appropriate number of degrees, and we'll do that using Desmos as usual. So for our first example problem, they want us to graph quadrilateral RTSU with vertices there. So let's go ahead and do what we usually do, put those vertices into Desmos. It helps if I have my fingers in the right place on the keyboard. As always, label these so we can keep track of everything. We've done this lots of times before, so this should look very, very familiar. Okay, that is my pre-image starting quadrilateral. We want to find its image after a 270-degree counterclockwise rotation about the origin. So let's write that out first, and then we'll put it in Desmos. If we're going 270 degrees counterclockwise, we're going to use this rule right here. The point AB turns into B, negative A. So we switch the x and y coordinates. Our starting x coordinate switches signs as well. So going point by point, R31 turns into R prime, 1, negative 3. So I switched the order, and the old x coordinate became negative when I did that. S51 is going to turn into S prime, 1, negative 5. T5, negative 3 turns into T prime, negative 3, negative 5. And then U2, negative 1, turns into U prime, negative 1, negative 2. So all those x coordinates started off as being positive. When they became y coordinates, we made them negative because of our rule here. Now let's see what that looks like in Desmos. So plot those points, label them. Since this is our image, they're going to be with primes. So that first one is R prime. I am typoing all over the place today. My apologies. And last but not least, here is U prime. So what's happened here is we took our original starting quadrilateral RSTU and we rotated it 270 degrees to turn it into R prime, S prime, T prime, U prime. Let's try another one. I'm going to get rid of all these things here because now we are starting with a different figure. We're starting with triangle ABC. 3, 1 is A. 3, 4 is B. And 1, 1 is C. How are we rotating it to get to its image? We are rotating 180 degrees counterclockwise. So let's look at our rules. If we are going 180 degrees counterclockwise, that's this one right here, AB turns into negative A, negative B. So things stay in the same order. X stays X, Y stays Y. We change the signs of both. So just like before, let's write out what's going to happen. 3, 1 turns into 3 becomes negative 3, 1 becomes negative 1 for my A prime. So keep the order the same, but just change the signs of both, X and Y. B3, 4 turns into B prime, negative 3, negative 4. C1, 1 turns into C prime, negative 1, negative 1. Let's put those into Desmos. Don't forget your primes since these are our image points. And there we have it. So we started with triangle ABC. We rotated it 180 degrees about the origin, counterclockwise, and it became A prime, B prime, C prime. One more thing we're going to talk about today is dealing with our rotation postulate and the fact that you might have seen this already, you might have noticed this already. Our rotation postulate says that rotations are a rigid motion. So translations were rigid, reflections were rigid, rotations are also rigid. The starting blue triangle here, DEF, when we rotate it about any point, through any angle of rotation, the side lengths stay the same, the angles of that triangle stay the same. Also, like we've talked about with composing either multiple translations or a translation and a reflection, if we combine rotations and reflections, since those are both rigid motions, the combination or composition of those will be a rigid motion also. So figures are staying the same size. They are just being rotated around, or in this case, rotated and reflected. So the last two things we are going to rotate and reflect today are line segments. They want us to graph the line segment RS with endpoints 1, negative 3. That's R. And 2, negative 6, which is S. And they want us to find the image after composition. We'll need to think about our reflection rules, which were back here, or sorry, rotation rules, which are back here, and reflection rules that we learned in a previous lesson. And I'll help you with some of those rules because we're kind of talking about a combination of rules. As usual, do the rotations, reflections, whatever, in the order you see them. So first, let's start with this reflection in the y-axis. Thinking back to when we talked about reflecting in the y-axis, our rule for that is AB turns into negative AB. The y-coordinate stays the same, the x-coordinate becomes negative. So R1, negative 3 turns into R prime, negative 1, negative 3. I made the x-coordinate negative, the y-coordinate stays the same. S2, negative 6 becomes S prime, negative 2, negative 6. So then let's put those into Desmos. To label them with primes because this is what happens after our first transformation. If we were just reflecting, we'd be done. However, we also need to rotate. When we rotate 90 degrees counterclockwise, let's look back at our rotation rules. Our 90 degrees counterclockwise rule is this one right here. AB turns into negative BA. So I'm going to take my r prime and s prime and do negative ba to those. So r double prime, I'm going to put my y coordinate first and then negative b, change the sign. So negative 3 becomes positive 3. And then a stays negative 1. S double prime, I'm going to put that y coordinate first. Negative 6 will become positive 6. Then our x coordinate, negative 2, stays the same. It just becomes the y coordinate. So now let's plot those. 3, negative 1. Label that, since it's after the second transformation, r double prime. And then same idea with s double prime. So we started with rs with the red and the blue, reflected it in the y-axis to get r prime, s prime, and then rotated it 90 degrees counterclockwise about the origin to get r prime, s prime, r double prime, s double prime. Nine degrees counterclockwise would be going this direction, as we can see here. All right, let's try one more. It's starting with the same starting image or pre-image, same pre-image. So I'm going to keep R and S and Desmos because those didn't change. But we have a new rotation and a new reflection. Since the rotation is first, we're going to do that first. Let's look back at our rotation rules. We're going 180 counterclockwise, which is the one I have with an orange star right here. 180 counterclockwise, AB turns into negative A, negative B. So let's write our work for that down there. R1, negative 3 turns into R prime. We change these signs of both of these. So 1 becomes negative 1, negative 3 becomes positive 3. Same idea with S to get S prime. 2 becomes negative 2, negative 6 becomes positive 6. Let's put those in Desmos. So I have negative 1, 3, R prime, and negative 2, 6, S prime. So that's what happened after we rotated 180 degrees. Now we need to reflect. Reflecting in the y-axis, we actually talked about that in the last example. AB turns into negative AB. So let's do that to get our final image here. R double prime, this becomes negative A, so negative 1 turns into 1. B stays the same, so it stays 3. S double prime, I change the sign of negative 2 to positive 2. The 6 stays the same. Bless you, Bella, my dog, if you heard her sneeze. Okay, let's graph those in Desmos. So 1, 3 is my final image for R double prime. 2, 6 is my final image for S double prime. So started with the red and the blue, rotated it 180 degrees counterclockwise to get to the blue and the green, R prime, S prime, and then reflected it in the y-axis to get R double prime, S double prime. That is it for today for rotations. Hope you have a wonderful day.